All right, so think and solve. Problem number 48 from chapter 4. 1 pound is the same as 4.45 newtons. What is the weight in pounds of 1 newton? At the end, they give a slightly different conversion factor. They say 1 pound is the same as 4.448 newtons. It's just a matter of rounding here. And so this is a straight up conversion since newtons and pounds both are units of weight. You can have a conversion factor there. And so again, setting up one ratio, 1 pound is the 4.44, or 1 pound is to 4.45 newtons, as X pounds is to 1 newton. And so you'll end up doing 1 divided by 4.45, and so whatever that ends up being. Number 49, if Lillian weighs 500 newtons, what is her weight in pounds? Again, this is a conversion. We just did the number of pounds in 1 newton. Doing it slightly differently, instead of setting up a ratio, you can just multiply by a fraction, which is the proper technique for doing conversions. So 500 newtons times, now we need to multiply by a fraction that's equal to 1, and a fraction is equal to 1 if the numerator and denominator are equal. So 500 newtons times 1 pound over 4.45 newtons gets you your answer. The newtons will cancel out because you have it on top and bottom. And so what you're left with is 500 divided by 4.45, or 448 if you want to use the number in the back of the book, and you get your answer in pounds. Again, whatever the numbers you end up with, the number, since a pound is more than a newton, it doesn't take as many pounds. My weight is about a little over 200 pounds, about 215 pounds, but 1,000 newtons. So when I'm doing that conversion, the number next to newtons better be bigger than the number next to pounds. Number 50. Consider a mass of 1 kilogram accelerated by 1 meter per second, accelerated 1 meter per second squared by a force of 1 newton. Should the acceleration would be the same for a force of 2 newtons acting on 2 kilograms. This, again, they give you mass and force, and so plugging into F equals ma is the way to go. So you have force equals mass times acceleration. 2 newtons equals 2 kilograms times acceleration. Divide both sides by 2, and you end up with 1 meter per second squared. This also, the fact that it requires more force to accelerate more mass at the same acceleration. And this is the essence behind objects traveling. If I take 2 objects at different weights and I drop them, that they'll fall at the same rate. Because the more massive object has more weight acting on it, but the more massive object is harder to actually get to move. And so it balances out. Number 52, Alex, who has a mass of 100 kilograms, is skateboarding at 9 meters per second. When he smacks into a brick wall, comes to a dead stop in 0.2 seconds. Show that his deceleration is 45 meters per second squared. Using slightly different language, let's assume that he's traveling in the positive direction right before he hits the wall. So therefore, his acceleration, since he's going to slow down, his acceleration will be the opposite sign, or negative. If we assume that his acceleration is negative to start with, if we assume his velocity is negative to start with, his acceleration will be positive. They'll be opposite signs if he's going to slow down. So, in essence, we have velocity, we have time. Acceleration is change in velocity over change in time. He's going from 9 meters per second to 0 meters per second, divided by the time of 0.2 seconds. Because the change in velocity is final minus initial. The final velocity is 0 meters per second. The initial is 9. So 0 minus 9 divided by 0.2, which is negative 9 divided by 0.2. This assumes his initial velocity is positive. Sorry. And then 9 divided by 0.2 is 45. So negative 9 divided by 0.2 is negative 45 meters per second squared. Show the force of impact is 4,500 newtons. And so that is, once we have the acceleration, we multiply times the mass to get the force. And so that's 52.